Och dra på knappen. Nej. Ja, jag ser inte Dravo. Ja, jag vet inte vad jag ska göra.
Hello, everybody.
All right. Very good morning, and let's start. As you maybe noticed, we had some technical issues because there's Monday morning, but I think we're okay to go now. All right, welcome to this APIS course. It's called 5G System Overview, and normally I would say when we don't have a pandemic, this is a 3-day course. So I've been to your office in Budapest a number of times doing this course in 3 full days, like 9 to 5. This time, since we are using Microsoft Teams, we can split it up to shorter parts. So actually, the whole week we will do the 5G System Overview course starting at 9 o'clock, which is now, and ending at roughly 1 o'clock, Monday to Friday. And if you have taken APIS courses before, you are probably familiar with the methodology we're using. So in front of you, you should have papers like this one, like big papers with some pre-printed information on it. And the simple idea is that I will, for the most of the time, draw things and write things on my computer program, which you see here. And if you take notes, if you write what I write, if you draw what I draw, you will remember more than if you just lean back and watch me do things for 5 mornings this week. Occasionally, I will show you some PowerPoint presentation, and in that case, you have the PowerPoint presentations somewhere in your mailbox. We sent them to you last week, I think. So there's no need to take in separate notes for when I show you PowerPoints. Great. A few more house rules. If you want to ask me questions or if you want to say something, well, don't say it, use the chat function instead. I think we have muted your microphones, and if we haven't done it, you can mute the microphones yourself. If everybody's microphones are on, there will be a lot of noises. There will be probably people in your house or dogs barking or traffic on the street. So we have found out that the best way to communicate is to use audio and video in this direction and chat in the other direction. So questions, comments, complaints, suggestions, whatever, use the chat function. And then probably once a day we will allow questions to be asked the kind of normal way, and we will unmute your microphone. So if you have like a longer question or if you want to discuss something, there will be at least one opportunity per day to really talk to me in the old-fashioned way. Great. I see a lot of people logged in. So they're kind of usual gang, a few Gabors, a few Laszlos, a couple of Sultans. So kind of the normal situation when doing courses for Hungarian people. Great. There will be, I think, 11 chapters, pictures, papers like this. And there will also be a few PowerPoint presentations, like I said. And I think I will start with the PowerPoint presentation. And I hope technology works now. It should. And I will do like this. And it doesn't really work the way I wanted it to. So I will try again, or I will ask my studio guy. PowerPoint is not working really like. Okay, this is better. Okay, so we don't really like long PowerPoint presentations because people tend to fall asleep sometimes. This is a fairly long PowerPoint. It's by far the longest PowerPoint in the whole course, but since it's Monday morning and since we've had coffee recently, I will try to introduce 5G with this PowerPoint presentation. So if you looked at Wikipedia a few years ago, or like 1 year, maybe 1.5 years ago, it said something like this: 5G is a marketing term for some new mobile technologies. Definitions differ and confusion is common. And I thought that was kind of funny because there has been for sure some confusion about what 5G is and what it isn't. It mentions something about IMT 2020. It mentions something about very high bit rates. It talks here about millimeter waves. And it mentions, of course, 3GPP standards and something about NR new radio. So despite the confusion, of course, there are some technical facts associated with 5G. So lots of pictures have been made about 5G. And this is from the European Commission. Why not? What is 5G about? And I think there are some people here, probably people with smartphones, but actually if you take a look at the picture, most of the things we see are not really about people checking email or surfing the internet. It's a lot of smart wearables, smart mobility, car-to-car communication, water quality, smart grids. I think it says e-health somewhere. So the focus here is on kind of new services, connected things, and healthcare involving 5G in some way, and of course communication to from between cars using 5G. So that's one way to describe 5G on high level. Another picture, this is from an organization called the 5G PPP, the 5G Infrastructure Public-Private Partnership. Here we have connected people. Obviously, we have connected transportation, but lots of connected things. It actually says here, connected things, so IoT, Internet of Things. There are clouds in the picture, and I think some of them, maybe this one and that one, is just a kind of normal weather cloud. It's a rain cloud. But you also see some clouds with information going into the cloud and up into this cloud and out from the cloud. And I think this refers to cloud computing, doing things in the cloud. We are entering an era of virtualization. So I suppose they mean that a lot of the things inside the 5G network will be deployed in some type of cloud environment rather than as standalone physical entities. Same organization, 5G PPP, claims that with 5G we will increase wireless capacity 1,000 times, which is a lot. It's also a kind of nice round number. And of course you can ask 1,000 times more compared to what? And I don't know, it doesn't show in the picture. But even if this is just 500 times more the capacity or 200 times more the capacity, it's still a big increase. So well, when I do this course in classrooms, like physical classrooms, I usually ask people how do we get, say, 100 times more capacity? And I usually get two answers. The first answer I get is usually, yeah, add new frequency spectrum. So yes, the millimeter wave frequency spectrum means that for 5G we will use frequency bands which are much, much higher than those we have been using so far for 2G and 3G and 4G. So more radio spectrum means basically more capacity. And the other answer to how do we get lots and lots more capacity is to, well, use more money, spend more money on the network. Operators will need to deploy 5G base stations very, very closely to each other. Good for you, because you will be able to send, hopefully, you will be able to sell, hopefully, a lot of radio base stations and other radio network related equipment. Of course, you will also sell 5G core network equipment. Yeah, 7 billion people. Yeah, that's everybody on this planet, more or less. 7 trillion things nobody knows. Also important is latency. So, well, strictly speaking, zero latency is maybe not even theoretically possible. But one of the main use cases for 5G, and we will come back to this in a while, is called ultra reliable low latency communication, or URLC. And some of the expected 5G services will require super short latency in the magnitude of milliseconds between the two kind of endpoints of the session. This is another way to describe 5G, this time from the GSM Association, which is the club for mobile operators. And of course, the name is historical. So nowadays, the members of the GSM Association are operators having not only 2G, but also 3G, 4G, and maybe also 5G networks. So it says here, there's a 5G antenna here and 5G radio signals here, but you also see other things in the picture. You see Wi-Fi zone. So is Wi-Fi 5G? And I would say no, Wi-Fi is not 5G. But in the kind of bigger 5G picture, in the kind of bigger 5G ecosystem, why not use the fact that a lot of the 5G devices will also support Wi-Fi? So maybe we can offload 5G traffic to Wi-Fi access points, pretty much like we offload 4G traffic to Wi-Fi access points. And actually here, I don't know if you can read it because it's in tiny font, but it says 5G plus 4G. So I think what the GSMA is trying to say here is that 4G can also be seen as part of the 5G ecosystem, the bigger 5G picture. And when we talk about new radio later on in this course, you will see that new radio is kind of designed to be, in a sense, backwards compatible to old radio or LTE radio, meaning that it's, for instance, possible to mix new radio and LTE radio on the same radio carrier in a very dynamic way. All right, this is a picture from you. Yet another way to describe 5G. There will be 5G devices. Some of them will be phones or smartphones or pads or pods or tablets. Where is mine? Like these kind of things. But as we also know, a lot of the 5G devices will be other types of things. Power meters, sensors, alarms, and even kind of more advanced things like industry robots. I think the assumption here is that a power meter maybe reports the monthly power consumption once per month. It's a few digits, while an industry robot communicates in real time with some production system, production server in a factory. So from both kind of capacity and delay perspective, this will have a much more demanding profile than a simple power or water meter. There is an access network, and it says wireless and wireline access. So in this course, we will focus on the wireless access, the so-called NG-RAN, the next generation radio access network. But let's not forget that things can also be connected to the 5G system using some, well, cable or fiber. There will be data centers with things that we will talk about, kind of core network things. There will also be applications like app 3 and 4. Here it says app 1 and 2, some application deployed in the access network. And that may sound like a little bit of a contradiction, because in 2G, 3G, and 4G, the radio access network has been responsible for radio connections, radio channels, radio quality. We haven't really had applications, services in the radio network. But if you have heard about edge computing or multi-access edge computing, MEC, this idea is about moving applications, moving services towards the edge of the network. And applications can be deployed using the same hardware equipment which we have for our radio network things. It says here cloud. So this picture assumes that things are deployed in some type of cloudified environment. I will come back to this later on too. By the way, I should have asked you a long time ago, but do you hear me and do you see me? Kind of a fundamental question. So if you hear and if you see and everything is okay, maybe you can type something in the chat. Great. A few yeses, so it means that the technology works. This was, of course, the first thing I should have asked you 20 minutes ago, but I forgot. Great. This is how 3GPP shows 5G, and this is quite much how I will describe 5G in this course. So what do we see? We see a user equipment, so some type of phone or smartphone or meter or sensor or a robot or car or refrigerator or coffee machine. UE, that's the terminal. And I suppose the purpose is that the user equipment communicates with something or somebody out here. DN is short for data network. So data network is 3GPP's way to say some external data network, which is not really part of the 5G system. This is a data network which the user equipment uses the 5G system to get in contact with. This could be, for instance, the public internet, very popular, well-known data network with cool services that the user equipment wants to use. This could be IMS, the IP multimedia subsystem, which we use for VoLTE calls today. I suppose with this setup, it would be a voice over 5G call because it's not LTE anymore. But if this is a water meter or the user equipment is kind of part of a water meter, I suppose that the data network is the water company's intranet where there's a billing server and the water meter will report last month's water consumption. If this is an alarm, this could be the alarm company's intranet where somebody monitors cameras and alarms and sensors, etc. So this is, I suppose, why we have a 5G, to allow user equipment to communicate with something or somebody out here. In order to make this work, we need to have a radio access network. We need to have user plane functions to handle the user plane, because the data will go this way. When you update Facebook, or when you stream Netflix, or when you, once again, this will be your user plane. And then in order to make things work, as we know, there has to be other functions. As you can see, most of these boxes here end with F, as in function. So we are not necessarily, once again, talking about physical entities. These are logical functions. For instance, when a user equipment is being switched on, it will need to register somewhere. This is why we have the access and mobility management function. In order to set up a session, we have the session management function. In order to store subscriber data, we have the UDM, Unified Data Management. In order to do authentication, we have the authentication server function. I will talk a lot about these boxes and these functions later on in the course. So what I wanted to show you is that there are different ways to describe 5G depending on if you are 3GPP or the European Commission or somebody else. This is going to be a technical course, so this is kind of my perspective on things. All right, if you read about 5G almost anywhere, you will very soon come across acronyms like, well, we can say API, but NFV, Network Function Virtualization. The collective name for this and this and this and this and this and also this is that they are network functions. And if they are deployed in some type of cloud environment, they are so-called virtualized network functions as opposed to physical network functions. So Virtualization of network functions, that's a very important concept in 5G. Network slicing, I'm pretty sure that you have heard somebody mention network slicing or network slices. And it's an important concept in 5G, and I will try to explain it later on in this course. Edge computing or multi-access edge computing, kind of moving at least some services, some applications towards the edge of the network, closer to the UEs, so that we can have shorter latencies and we can also benefit in other ways from edge computing. APIs, I think everybody has heard about APIs, and at least I think we hear more about it when we talk about the kind of IT world or the traditional IT world. But I mean, now telecom is becoming IT. So there will be APIs in these virtualized network functions, and there's actually, in a sense, an API from the whole 5G system, which allows the outside world to communicate with the 5G system. If you've heard about the network exposure function, this is the one I'm talking about. So almost wherever you read about 5G, it will mention network slicing, it will mention NFV and also SDN, software-defined networking. It will mention VNF, virtualized network functions, which gives us a new level of flexibility. There will, of course, there will be other terms which will also appear in PowerPoint presentations and white papers over and over and over. All right, some numbers. I think sometimes in the telecom business we are a bit too obsessed with bit rates and capacities, but let's take a look at some of the 5G numbers. And some of the numbers originate not from 3GPP, but from ITU, the International Telecommunications Union, R as in radio. So a couple of years ago, I think it says 2017 somewhere here, there was a report saying minimum requirements related to technical performance for IMT 2020. It doesn't say 5G, but this kind of corresponds to 5G. IMT as International Mobile Telephony or Telecommunications. So the kind of requirements were basically set by the International Telecommunications Union, and just to highlight a few numbers, they say that peak data rate shall be 20 gigabits per second in the downlink, 10 gigabits per second in the uplink. User data rate 100 megabits per second downlink, 50 megabits per second uplink. This doesn't mean that every cell in every 5G network on this planet will support these data rates. This means that it shall be possible for somebody, an operator or a company, to build a network with these capacities if needed. But if you've ever been to Sweden or northern Sweden, you know that there's absolutely no reason to have these capacities in the far northern part of Sweden, because nobody lives there, nobody goes there. It's dark, it's cold, it's horrible. but the specifications should allow somebody to build a network with this capacity somewhere. Yeah, user plane latency. So once again, it shall be possible to build a network with these low latencies. Of course, in order to check email or update Facebook, you don't need this. But maybe in some production factory, or maybe for some remote surgery, or maybe for car-to-car communication, we actually do need millisecond level latencies. I will not go through all the numbers, but I think this is interesting. Connection density, 1 million devices per square kilometer. So once again, it shall be possible to build a 5G network that can handle 1 million UEs per square kilometer. That's a lot. And I think the assumption here is that many of these will be things, meters, sensors, maybe cameras, that don't necessarily generate very much traffic, but still they have to be registered in the network, they have to be known in the network will need to store identities, various numbers, etc. So just the number of devices can be a challenge for the network. Maybe it's not the traffic load which is the biggest challenge sometimes. All right. Also, I will not talk about everything in this picture, but if we take a look at, well, it says here NGMN, Next Generation Mobile Network. We can roughly translate this to 5G. And here we have a number of use cases or expected use cases, expected data rates. And if we take a look at this use case, indoor ultra-high broadband access, you can imagine airports, shopping centers, maybe offices, a lot of people are uploading and downloading things. User experienced data rate, well, at least in the magnitude of gigabits per second, or in the uplink 500 megabits per second. That's a lot. Also the end-to-end latency, 10 milliseconds, that's short. So that's kind of tough requirements. On the other hand, if you take a look at this use case, massive, low cost, long range, low power, MTC as in machine type communications. These are lots of probably simple, cheap things which will maybe report that temperature at 9 o'clock was such and such, or humidity was 50%. Typically the bitrate requirements are very modest, and also the delay requirements are kind of loose, seconds or sometimes even hours. So how do we build a network which can handle very high bit rates, very low latencies in an efficient way, but also lots of connected things with very modest requirements in an efficient way, not to mention all the other use cases we see here. It's like if somebody tells you to design a car, and in the requirement specification it says it has to be a sports car, but it also needs to be a family car, and it needs to be a truck, and it needs to be such and such type of car. I mean, that's almost impossible. So how do we build a network which can handle these very diverse requirements? And the answer is network slicing. So I borrowed this slide from Huawei. I had an Ericsson slide before, so I think to be fair and balanced. But it's a good slide. I think your equipment is better, but at least this slide is nice. Physical infrastructure, yes, of course, there will be physical base stations. There will be data centers with servers and computers and storage. There will be switches and routers and fibers and cables. I mean, real physical things which we can touch and move and hit if we get angry. The idea is that we will divide the resources of these physical things into different so-called network slices. So some part of the radio resources, some part of the core network resources, some part of the computing resources, some part of the memory resources, some part of the transport network resources is in this case allocated to an EMBB slice. EMBB means enhanced mobile broadband. So mobile broadband, like we've had for 10, 15 years, but enhanced, more capacity, higher bit rates, shorter delays. And in the same way, some of the radio network resources, some of the core network resources, some of the intelligence memory is allocated to an URLC slice. And unfortunately, URLC is an well accepted acronym in 5G. It's kind of difficult to say and it sounds ugly, but URLC means ultra reliable low latency communication. So we have an URLC slice for services that require very high reliability and or very low latencies. And in the same sense, we have an MMTC slice. MMTC means massive machine type communications. Sometimes this is called massive IoT. So lots of connected things. And in some clever way, and I will try to explain this later, the totality of network resources has been allocated to, in this example, 3 different network slices. This is another slicing picture from GSMA. I think it looks a bit complicated, but the reason I'm showing you is that here we have a network slice for utilities like meters and sensors. There's one automotive slice and there's one manufacturing slice. So how many slices there will be in a network and exactly what these slices are used for, that's up to the telecom operator or the company, if we talk about the private network, to figure out which network shall we have in our, which slices shall we have in our network, what different services do we expect to handle in our public network or in our private 5G network. All right, these 3 Huawei slices, they correspond to the 3 main 5G use cases that I think everybody has more or less adopted and say that, okay, 5G on high level, it's about 3 main use cases. Enhanced mobile broadband, so basically same service as before, but better, faster, more. Massive machine type communications, connected things, and of course, as we know, we've had connected things in LTE or over LTE. There are even LTE flavors targeting things. If we talk about narrowband IoT and LTE-M, and actually there are connected things using 3G and 2G. In our house in Stockholm, the alarm is connected over 2G. It works fine because usually nobody breaks into the house, and if somebody does break into the house, 2G is enough to inform some security company that there's a break-in. So the new thing here is the number and maybe also the diversity. Some of these connected things will require low bit rates and very modest delay requirements. Other things will require much more capacity, etc., etc. And like I said, the number of connected devices will probably increase in the next few years. And then we have the third use case, the URLC use case. So mission critical services, e-health, if we talk about self-driving cars, if we talk about factories, industries, production plants replacing their cables with 5G. This is the third main use case. Yeah, this is the same, I think, what I said, more or less. We will not repeat that again. All right, another thing which is very much part of the 5G picture is edge computing. And I found this picture from Korea Telecom because I think it's simple and nice, and it explains what edge computing is about. So this is basically how 4G works, at least very often. There are LTE users and there are E-Node Bs distributed all over South Korea. The core network, the MME and the S gateway and P gateway, etc., very often centralized to a few data centers somewhere kind of further into the network. And then you have the applications kind of behind the core network. You get internet access, you have your IMS system, you have other applications kind of behind the core network. In 5G, the idea is that we have the possibility at least to decentralize the 5G core, or at least part of the 5G core. Here it says 5G core user plane. So the so-called user plane function that actually handles the user plane. In 4G, this red rectangle is up here. In 5G, we have kind of distributed the user plane part of the 5G network closer to the edge, closer to the UEs, which also means that we can decentralize the applications, or at least latency sensitive applications can be distributed so that we also have these purple boxes towards the edge of the network. And from a delay point of view, this looks like a shorter delay, a lower latency than this type of communication. So, do you remember this Wikipedia quote where they said that definitions differ and confusion is common? By the way, it doesn't say so on Wikipedia anymore. So that quote is a bit outdated. And I think nowadays, I think everybody more or less would say that, yeah, 5G, it's about more mobile data capacity. Once again, we will use more frequency spectrum for 5G than we have been using previously for 4G and 3G and 2G. And more radio spectrum gives higher capacity. Also, of course, like I said, more base stations give higher capacity. Higher bit rates, yes, of course. Low delay, sure. Or at least the possibility for low delay. Once again, in order to send email or get an email from the web server, sorry, from the mail server, this is not delay sensitive. So why kind of push low delay requirements for all services? That doesn't make sense. But services that are delay sensitive can be handled in the 5G network. Yeah, if you remember the URLC use case, ultra reliable, low latency communication. So with 5G, it shall be possible to step up reliability compared to previous generations. Virtualization, network slicing, cloud technology, I think they kind of belong together. Virtualization and cloud are related, obviously, and actually one reason why we can create network slices is because we expect a lot of the things to be virtualized. I will come back to this later this week. Different access technologies working together. Yes, there is something called new radio, which is the 5G radio, but once again, in the kind of bigger picture, also 4G will be used, also Wi-Fi will be used, because I mean, obviously, I suppose all the 5G smartphones will also support Wi-Fi. So why not try to have some type of interworking between new radio and Wi-Fi when possible? Edge computing, moving services closer to customers, and lots of connected things. I don't know if there's a number called zillions, but the point is everybody expects a lot of things to be connected over 5G. I think most people would agree upon most of these things. All right, I think I will stop there. This was, like I said, by far the longest PowerPoint presentation because we don't really like these long PowerPoints. But now it's over and it's 10 minutes to 10. Why not have a coffee break? And then after the coffee break, we will take our papers and pens and we will start to draw and write things. So whatever your watches are now, be back in 10 minutes. But, oh. Är ljudet på?
På själva programmet, ja.
Ja, just det. Ja. Great. Okay, let's continue. I just one little remark about this comparison between 4G and 5G. And maybe you already know this, but virtualization can be done also in 4G. I mean, probably you have solutions for virtualized evolved packet core. So it's not like virtualization is only possible in 5G. It was not possible in 4G. That's not the case. Same thing with edge computing. Yeah, we can do edge computing in 4G, moving services, applications closer to subscribers. But 5G is kind of more or less designed from scratch to have the possibility of edge computing. But it's edge computing is not limited to 5G. All right, time to look at our papers and use the pens. And the first chapter paper lesson will be an introduction, an overview of the 5G system. Or actually, it's the lower part of the picture is 5G. This will be the next generation radio access network, the 5G core network. The upper part, at least so far, is pretty much 4G. If you recognize, I can zoom in a bit. E node Bs, MMEs, S gateways, P gateways, the HSS database. By the way, I suppose that you, or at least many of you, have pens and papers in front of you. If you use them, that's good, because you will remember more than if you don't. Actually, taking notes and writing and drawing things is good. There's some type of link from our hand to our brains. If your handwriting is not as beautiful as my typing here, don't worry, because after the course you will get the official PowerPoint or PDF pictures sent to you. So don't worry about your handwriting or even having a bit of coffee on your papers. It's okay, but the kind of writing exercise is good for your learning. All right, so what do we see? Well, out here to the right is a packet data network. In 4G, this is called a packet data network. In 5G, for some reason, they use the expression data network. It's the same thing. They've just changed the terminology. And once again, this is some external data network, which is not part of the 5G system or the 4G system. 4G kind of ends here, 5G ends here. So this is outside the 5G network and 4G network. This is, once again, the public internet or the IP multimedia subsystem or some other service network, maybe a corporate intranet, maybe the electricity company's billing network or the water company's billing network. So we can give some examples here. Third-party service network, some utility. I can zoom in a bit. So if you have problems reading, just tell me so or type so in the chat and I will zoom in more. As long as I don't hear anything or see anything from you, I assume things are okay. Or maybe the user equipment sits inside a car, some modern fancy Tesla or BMW or a connected car. and the car will report to the car manufacturer's service network that the engine is running fine, or fuel consumption is a little bit too high, or I will need maintenance within 1 month because something is not really what it should be. And in that case, yeah, the data network or the packet data network, I suppose, is the car manufacturer's service network. Or maybe the UEs are street lights in Budapest, or all these trams that drive around, and buses that will report to the Budapest smart city network where they are and in which direction they are going, etc., etc. Maybe garbage bins will report that they need emptying, etc., etc. So we can also imagine some smart city packet data network. And ... Whenever I write ... I mean something else. And up here in the packet data network, we have something which is called AF, application function. This is the term the acronym 3DPP uses. I think most other people would say application server. So this is some application server providing some type of application that the UE wants to use. All right. In the 4GCore network, we have things which are hopefully familiar. We have the MME for mobility management. We have the big subscriber database, HSS. We have S gateways and P gateways for the user plane. They also handle session management. They are involved in setting up so-called PDN connections to some packet data network out here. We're not going to talk about the 4GCore network that much because it's supposed to be a 5G course. All right, and then we have the LTE radio network, or EUTRAN, which is the official name, with E-Node Bs. There are some interfaces here. For instance, between the E-Node B and the MME, when the E-Node B and MME need to discuss something, they can do so. This interface is called the S1 MME interface. And now I will introduce some color codes. So up here in the corner, it says control plane and user plane. And we will use red as our control plane color. So red lines and sometimes red text will be for different types of control plane signaling. And we will use green for the user plane for the web browsing or email or watching Netflix or listening to Spotify. That will be green lines. And this particular interface between the E-Node B and the MME is called the S1 MME interface, and it's red because there is never any user data traffic going this way. There's only control plane signaling. The user plane traffic the data traffic itself will go from the E node B to the S gateway in this direction, and of course vice versa. And this is called the S1U interface. And it's a green interface. U as in user plane. MME because this is the MME. Of course, the logical naming would be S1C as in control plane and S1U as in user plane. But sometimes things are not logical. Not even in the telecom world. All right. By the way, if you wonder why I talk about 4G in this 5G course, there's actually a good reason for it. So if you hang on a few more minutes, you will understand why. This 4G base station, the E node B, uses LTE radio to communicate with LTE UEs. So this gray arrow here represent, we can use black, 4G radio. The official acronym here is EUTRA. Evolved UMTS terrestrial radio access. That's the radio technology. This is the evolved UMTS terrestrial radio access network. I think most people would just call it LTE radio or 4G radio. So when we are using our 4G devices to get internet access or communication with some data network, green data traffic, green user plane traffic will basically travel across the LTE radio interface. And then via the E node B, the traffic will go over the S1U interface into the S gateway. And then traffic goes via the S gateway and via the P gateway. And once again, this is really where the 4G network ends. But of course, the traffic itself will continue and go into internet or IMS or to some third-party service network, some type of packet data network. So we can just indicate that the traffic goes into the packet data network. If you have internet access over 4G, we say that you have a PDN connection. You have a PDN connection to a certain packet data network. If we investigate this green line a bit more in detail, you will find out that There are things like EPS bearers. There is a default EPS bearer. There may be dedicated EPS bearers if you are familiar with that type of 4G terminology. All right, so that was 4G. What we now can do is that we can make it 5G in a very simple way. If we add a 5G base station here, then this becomes 5G. And maybe you know that 5G base stations are called G node Bs, like the letter G node B. Here we have E node B. I think they just wanted to skip the letter F to avoid funny jokes, and they decided for G node B. Maybe it has something to do with next generation. I don't know. It's just a name. Now, this is a G node B because over the radio interface, it uses 5G radio or new radio. Oops. Like this. Or simply NR. And new radio, believe it or not, is the official name for the 5G radio technology. Because it's new. In a couple of years, it will not be so new anymore. And in 10 or 15 years, it will be old. So I don't think the name is particularly good, but then again, they didn't ask me. All right, there was a comment from Sultan Shabo. I'm not sure about the pronunciation. At least a few of us did not receive this paper or the slides either. That's a pity. We sent the papers to somebody in your office, and the idea was that they should be distributed to you. I will look into it, not right now, but after the training today, I will see if we can find the papers, and I will also make sure that you get the PowerPoint presentations. I mean, that's obviously easier. That's just an email. The physical papers and pens require some physical transport. I will try to solve the problem. All right, so this is a G node B. It's a special type of G node B because it only works in pair with an E node B. And the official name for this thing is, hang on, an EN G node B. EN is short for E-Ultra New Radio. So this radio technology combined with this radio technology in G node B. What we can do now is that we can give the user equipment. Where is the user equipment? We can give the user equipment in parallel radio resources, both from the E node B and from the EN G node B. So for the same session, for the same data transfer, there are suddenly two radio connections. If we want to, or actually not if we want to, if the network wants to, because the network decides. But if we want to, or if the network wants to give this user equipment higher throughput, more capacity than you would get here, the network can also decide to set up a radio connection like this. And then the EN G node B will forward the data I will make a straight line. And the E node B will combine the data if we talk about the uplink communication in the downlink direction for incoming data. Well, some of the data can be sent that way. Some of the data can be sent that way. Or maybe the E node B will duplicate all the data, so everything will be sent both that way and that way. Maybe it sounds like a waste of radio resources to send the same information twice, but on the other hand, it sounds like it would increase the reliability, right? Instead of having one radio connection, if you have two radio connections, that sounds like, yeah, stepping up the reliability a little bit. All right. Yeah, obviously there is an interface which allows the EN G node B and the E node B to talk to each other, to forward data. This is the same old interface that we normally have in the LTE radio network. It's called the X2 interface, like this. And basically, it allows neighboring base stations to talk to each other. And when I say talk, I mean to exchange control plane signaling messages, and also obviously to exchange green user plane data. All right. If you've heard about non-standalone new radio, this is it. Non-standalone. I think they write it like that. NSA. New radio. The reason why it's called non-standalone new radio is that the ENG node B simply doesn't work on its own. If we take away the E node B, this one kind of dies. It simply cannot manage by itself. So that's the reason for the non-standalone expression. And actually, the relationship between the E node B and the ENG node B is that this is it's actually called the master node. It is what it sounds like. It controls things. It will activate or deactivate this, and this is kind of the boss of the operation. It's called the master node. Which makes this not the slave node, because I think it has a bad sound to it, but it's called the secondary node. So the master node will be the master of the secondary node. So we can write that also as a little comment. Maybe it's already clear, but just to be over clear, the ENG node B needs the E node B as master. If you heard about option 3, this is sometimes also referred to as option 3. Obviously, there is a option 1 and option 2 and etc. etc. I think I have a slide about it in a while, but if you have heard or seen or read about option 3, this is it. All right, is this 5G? It's still the 4G core network, the Evolved Packet Core. We still have eNode Bs. Actually, we depend on eNode Bs. We add a G-Node B or an EN G-Node B. Does this mean that we get 5G? And the answer is yes. Because we have decided so. I think you could question that. You could say, well, is it really 5G? Because we still have the 4G network. We still depend on 4G base stations. But we, the industry, I mean, not least you guys, I think, and of course the operators. I mean, we've had 4G LTE for 10 years now, and it sounds like a good idea from a kind of marketing perspective to have a new G. So this is what is being marketed now as we speak as 5G. In the morning newspaper today, there was one of the Swedish operators saying that now we are upgrading the 5G network to 25 new cities. This is what we call 5G. I would like to put it like this. I would like to write like this. This is early 5G. Because to be honest with you, I'm not 100% comfortable with calling this 5G. I know we, the industry, has decided that it's 5G, but I mean, there are no network slices here. It's, like I said, it's still the 4G core network, but okay. If we had decided to call it 5G, I mean, I will accept that. But my workaround is to call it early 5G. What does this look like? It looks, for instance, like this. We have the Evolved Packet Core, 4G core. We have our 4G cells, the LTE cells, the kind of grayish, or maybe they're just plain white. An eNode B. And then typically on selected places, train stations, airports, shopping centers, office areas, there will be cells using new radio, and there will be EN G-Node Bs quite often as on some higher frequency band, not necessarily millimeter wave, but 3.5 gigahertz or so. And as you may know, the higher frequency band, the shorter the radio signal will go. So these cells are typically smaller. eNode B and EN G-Node B can be co-located, of course. That sounds like a good idea. And what I've also tried to indicate is that the radio equipment in each yellow cell is not necessarily a complete big base station with all the functionality. Maybe what we will actually have, or what we actually do have on these rooftops and inside these airports and train stations, are just a kind of radio part of the base station, and the other logic is somewhere else. Later this week, I will talk about the possibility to split a G-Node-B into different physical and logical parts, like I think they call it a baseband unit and a remote radio unit. And maybe we only have the remote radio unit distributed. So it means that if you have a user equipment which can do both LTE radio and new radio, and you are inside a yellow area, you can have higher bit rates. Of course, if you are here or here or here, and you're outside the new radio coverage, it's 4G business as usual. Yeah, I also mentioned option 3, and yeah, in some document a few years ago, they named different basic combinations of radio network and core network. So option 1 is the 4G core network and the 4G radio network. That's basically 4G. Option 3, what I just talked about, is 4G core network, E-Node-Bs acting as master nodes, and then EN-G-Node-Bs, secondary nodes, giving extra radio resources, extra radio capacity for early 5G. All right, I'm looking at the chat window, but it seems we're okay. All right. In order to make this work, obviously the user equipment will need to be a 5G enabled user equipment. So I'm kind of waving my iPhone every once in a while, but to be honest with you, this is a 4G iPhone, so not same. So in order to make this work, the user equipment has to be able to support obviously LTE radio. It's an LTE user equipment. It's also a new radio user equipment. And as you probably know, there are more and more 5G devices being released to the market, more or less month by month nowadays. Still, when the user equipment registers in the network, when the user equipment asks for a PDM connection to be set up to the public internet or IMS or to some smart city network, the signaling towards the core network goes to the MME. Signaling between the user equipment and the core network, this is called NAS signaling, non-access stratum signaling. It's not radio-related signaling. This is signaling about registering in the network, mobility updates. I have moved into a new tracking area. Can I please have internet access? Yes, you can. This is still the 4G type of non-access stratum signaling. So we can just indicate with an, well, there's already an arrow here. We can indicate that this refers to the 4G type of NAS signaling. And obviously, the core network is not really that interested in if the user equipment is using only LTE radio waves or also new radio waves. I mean, basically the core network doesn't care about what type of radio waves we are using. Having said that, the MME will know if the user is doing this is called dual connectivity. The MME will know if the user equipment is in dual connectivity mode or is it not, but the MME doesn't really care about it. Well, it cares a little, but it doesn't care a lot about it. All right, and then, as you probably know, we also have the possibility to use some non-3GPP access. If we are somewhere where LTE coverage is bad, but there's a nice Wi-Fi access point at home or in a hotel or cafe, it's also possible to connect people using Wi-Fi and some fixed broadband connection on the edge of the 5GCore network. We have the so-called EPDG, which is some type of, you can call it a security gateway when you are using some Wi-Fi access network instead of the operator's radio access network. Great. So, E-Utran LTE radio access network, and now we have kind of upgraded it with new radio. All right, so I called this early 5G. This will be kind of real 5G, the kind of proper 5G solution. So what does that look like? I think we will, we will start to talk about it. We will start with the core network. Then we will have a break in a couple of minutes. But let's go on for a few more minutes. Once again, for some reason, in the 5G specifications, they talk about data network instead of packet data network, but they mean the same thing. This can be the public internet, this can be IMS, this can be some third-party service network. There are application functions here. Like I said, I think most people would call it an application server, but for some reason 3GPP calls it application function. All right, Sultan, one of the Sultans. I have just requested the PPT files. Hopefully everybody got it in the last minute. Okay, maybe things are working as they should. Great. So 5GCore network, which is officially called the 5GCore network. Brilliant name. Straightforward, uncomplicated. I suppose in any system where we have subscribers, there's a subscriber database to store identities and profiles and etc. etc. In 2G and 3G it was called the HLR, the home location register. In 4G it was called the HSS, home subscriber server. In 5G it's called the UDM, Unified Data Management. So that's the kind of 5G subscriber database. We can just write a little memory note here. Subscriber database. We will take a closer look later on, but no surprises. It contains the things you would expect a subscriber database to contain: identities, profiles, preferences, some security related parameters, etc. All right. When a 5G user equipment out here is being switched on, it will register in the 5GCore. It will say, good morning, this is who I am, my identity, can I please register in the 5GCore network? And the registration will be done in the Access and Mobility Management Function, or AMF. So as the name suggests, one of the responsibilities is mobility management. The AMF will keep track on where, or at least roughly where, the 5G user equipments are. So we will make a little memory note about that. If you need more time to write, please tell me so in the chat. In a physical classroom, I will typically see if people are writing, but in the virtual world, I'm not able to see. But if you think I'm writing too fast or I'm not leaving you enough room to write, tell me, and I will improve. Yeah, before the subscriber registers, there will be some authentication procedure, just like in 2G and 3G and 4G. The 5G network will make sure that the subscriber is who he or she or it claims to be. So many of these procedures that we know from 2G and 3G and 4G, they are at least on high level same or at least similar in 5G. All right, in order to set up a session to some data network, the user equipment will tell the network, I would like to have internet access or IMS access, or I would like to have access to the Volvo or Tesla intranet if the user equipment is a car. In order to set up sessions, in order to manage sessions, in order to terminate sessions when they're not needed anymore, we have the session management function. Session management is the main and almost only responsibility of the session management function. So it will handle everything related to setting up sessions, modifying sessions, releasing sessions. We will come back to this later in the course, of course. The session itself will not go by the session management function. There will never be any email or voice over 5G packets or Netflix movies passing the session management function. The session itself will go via the user plane function. And in a session, there will always be minimum one user plane function. As we will see later, there may be multiple user plane functions. They can be after each other, or they can even be in parallel to each other. But if there is a session, there is at least one user plane function, which means that when a 5G user equipment has some 5G session up and running, the user plane or the data traffic, whatever we like to call it, will go over the 5G radio interface. Radio technology here is NR, as in new radio. There will be a G node B, and this is just a regular G node B, not this type of G node B. This is just a normal 5G base station. And the data traffic, if we continue the green line here, will go from the G node B into the 5G core network. This is really where the 5G network ends. But the data traffic itself, the IP traffic, for instance, will of course continue into the data network, because this is where we have the application servers. This is where we have application functions. But the responsibility of the 5G network ends here, basically. What happens outside the 5G system, 5G cannot be held responsible for. And a green line in 5G, which is used for communication between a user equipment and a data network. This is called a PDU session. PDU means protocol data unit. So a PDU session is the equivalent in 5G to a PDN connection in 4G or a PDP context in 2G and 3G. And of course, nobody except us telecom people will have any idea about what a PDU session is. If you ask the kind of average person on the streets of Budapest or Stockholm, they will just say, I have internet access, or I have access to the intranet at work. But the proper name in 5G is a PDU session. All right, so before we take a break, yeah, typically for a session, there will be some policies implemented. Policies typically related to quality of service. Is there a guaranteed bit rate here? What's the maximum bit rate? How important is this session compared to other sessions? How many packets can we afford to lose? Remember, once again, the idea is to handle lots of different use cases, some of them requiring ultra reliability. Some of them are just a thermometer reporting that the temperature in Stockholm is 12 degrees. So typically for a session, there will be a set of policies, and they will originate from the policy control function. So when a session is set up, the session management function can ask the policy control function, do you want me to implement or enforce any particular policies? So in short, the PCF is for policy control. The slightly longer explanation of the PTF, if you're interested, is in a 2-day course. Policy control in 5G, it's a big topic, and we have a separate 2-day course only about that. All right, if we compare the 5G core network with the 4G core network, we will of course see that there are similar things. There's a subscriber database here. There's a subscriber database in the 4G core network. The AMF does mobility management in the 5G core. The MME does mobility management in the 4G core. Session management is kind of the responsibility of one function here. Whereas in 4G, in order to set up a session, well, the MME is involved, the S gateway is involved, the P gateway is involved. So session management in 4G core is a kind of split responsibility. Whereas in 5G, they said, let's have one session management function. In 5G, they have split session management from the session itself. Because actually managing a session is quite a different task than handling the session, shuffling packets back and forth. And maybe remember that in the 4G core network, we also nowadays have the option to split session management and the user plane. There's something called CUPS. CUPS, control user plane separation, which means that also the P gateway and the S gateway can be split into two parts. One control plane part, which does session management, and one user plane part, which handles the user plane. So from a high level functional point of view, the things that the 5G core network does is quite similar to the things that the 4G core network does, which of course makes a lot of sense. Then there are some completely new things in 5G. For instance, in 5G we have the concept of network slicing. And in order to figure out what equipment that belongs to a certain network slice, we have the network slice selection function here, the NSSF. And of course, in 4G, since we don't have network slices, we don't have any equivalent to the network slicing function. Dot means that there are also other rectangles or boxes in the 5G core network. This is so far just a simplified picture. All right, let's have a 10-minute break. I think you might need coffee or tea or some fresh air. So I will set the timer for 10 minutes, and after that we will continue. All right, great. Let's continue. So yeah, we discussed the 5GCore network, and now we can move over to the 5G radio network. Official name, NG-RAN, Next Generation Radio Access Network, which is also a so-and-so name, because when we have it, it's not the next generation RAN anymore, it's the current generation RAN. And then in a few years, it will be like the previous generation RAN. But once again, that's the name. And we have, G node Bs. We also have a strange kind of E node B here, which I will come back to in a while. All right. This G node B can handle this user equipment perfectly well on its own. It doesn't need help from another base station. So this is called standalone new radio, because this one works on its own, this one works on its own. They can work together, but they do not necessarily need to work together. So if you have heard about standalone new radio, this is it, and this is also referred to as option 2. I'll zoom in a little bit. And standalone means that, the G node B works by itself, so to say. No need to have this master node, secondary node relationship. And if we have G node Bs and the NG-RAN, if we have the 5GCore network with the stuff we talked about before the break, this is real 5G or true 5G. Now we have the possibility to create network slices, etc. So I sometimes call it like true 5G. Still, there is the possibility to use radio resources from more than one G node B to give, say, this user equipment a higher throughput or higher reliability. The 5G network can do that, but it's not necessary to do that. This is called dual connectivity. A user equipment which is connected to more than one base station has like multiple radio connections. This is called dual connectivity. And in order to optionally put a user equipment in dual connectivity mode, there's also this interface between G node Bs so that they can talk to each other, discuss this possibility. This is now called the XN interface. Like this. Which we'll talk more about later on in this course, but it's as you can figure out, it's the kind of equivalent to the X2 interface in LTE. Now it's called the XN interface. All right. It says NG here. NG is a name for the interface or the border between the NG-RON and the 5GCore. So I think quite early in the specifications, they defined the NG interface as the kind of borderline between 5GCore and NG-RON. That's why it says NG. But there are, of course, individual interfaces as shown here between the G0B and the AMF. So occasionally, quite often, control plane information will need to be exchanged between a G0B and an AMF. And this is called the N2 interface, and it's a control plane interface, so we will use the red color. Or at least sometimes it's called N2, but unfortunately it has two names. So sometimes in some specifications you will see the term NGC. We will talk more about this Wednesday or Thursday, I suppose. In the user plane, we have this interface between the G0B and the user plane function outside the picture. It is called N3 sometimes, but also this interface has two names. So in some specifications, it will be called the NGU interface, and at least there is some type of logic here. C is of course for control plane and U is for the user plane. Great. By the way, I investigated the papers and pens, and it turns out I was misinformed a bit. So what we have sent to you, to Ericsson Hungary, were just PDF files, and they were sent to somebody called Serkan, S-E-R-C-A-N. I suppose it's a first name, or maybe it's a last name. And then the idea was that you would print these papers yourselves, and whether it was Serkan or you, I don't know. So maybe there's been some miscommunication somewhere, but the guy on your side, or maybe it's a girl on your side, is Serkan. I hope that helps. All right. So this user equipment is obviously a 5G user equipment. It can handle new radio. So how did we put it up here? I said LTE user equipment, NR user equipment. This is an NR user equipment. All right, great. Is it also an LTE user equipment? I don't know. Maybe, maybe not. If we know that this will stay where there is 5G coverage, I mean, there is no reason for it to support 4G or 3G or 2G. So if this is a thing which stays inside a geographical area where we know we will have new radio coverage, I mean, what's the point of having LTE support? On the other hand, if this is this type of device which moves around a lot, and sometimes there is 5G coverage and sometimes there is not, of course it makes sense that the user equipment supports both new radio and LTE radio, and maybe also 3G and 2G radio. From a NOS signaling point of view, when the user equipment registers, it will register in the AMF. When the user equipment wants to have internet access, it will talk to the session management function. It can ask to be registered in a certain network slice. So the NOS signaling, the non-access stratum signaling, contains slightly different messages and slightly different parameters than the 4G NOS. So this user equipment, and I know that, it speaks 5G non-access stratum signaling. So 5G NOS signaling. As opposed to this user equipment, which speaks 4G NOS. So if a user equipment is a 4G or 5G user equipment, it doesn't only have to do with the radio capabilities, it also has to do with the NOS signaling capabilities. In order to register in the 5G core, you have to be able to talk to the 5G core network. So this line or arrow here, that represents the 5G NOS signaling for registration, for session setup, for mobility management between the user equipment and the AMF. In 5G, this interface has a name, and it's called the N1 interface. So this has an official name, N1, and it's used for 5G NOS signaling. All right. Yeah. This is another N2 interface. This is another N3 interface from this G node B. If you want to write N2 and N3 here, you can do so, but why not? I was going to say I will not, but I changed my mind. This is N2 and this is N3. By the way, in this picture, I have drawn the G node B as a rectangle and a big antenna tower outside it, which could be true. G node Bs may look like that, some type of hardware and software and an antenna tower with radio equipment outside it. But they do not necessarily look like that. So I will just fast forward and show you something which is, I think, in chapter 7. As a little detour here. How do I do that? Yeah, like this. From an implementation point of view, it is possible to split the G node B into separate logical and physical parts. And this has already been done in 4G, so this concept is not new at all. But the 3DPP terminology and the 3DPP way to do this is to have a central part of the G node B and then a distributed part of the G node B. The distributed part contains the kind of radio close things, and the central part contains other types of radio resource management functionality. So I will return to this obviously in chapter 7, but just as a little note here, the G node B can and very often will be distributed, meaning that part of the G node B functionality sits in one place, but other parts, typically the radio close parts, are distributed where subscribers, where UEs are. All right. So we said earlier that there can be G node Bs in the LTE radio network. Maybe it sounds a bit like a contradiction, but I hope I explained the idea. And vice versa, we can also have E node Bs, LTE base stations or 4G base stations in the NG RAN. And in that case, we call it an NG E node B, next generation E node B. And it is an E node B in the sense that over the radio interface, it's LTE radio or E-Ultra radio, 4G radio. I will write like this. So the radio interface is LTE. But on the other side, the interfaces to the core network are the 5G interfaces, N2 and N3, same interfaces that we saw here. So I will just indicate this is N2, this is N3. So looking at it from this side, if we ask the core network will say, yeah, it's a base station. I'm not even sure that the core network sees the difference between this base station and that base station, because the interfaces, the protocols are the same. But of course, on the other side, it's a huge difference because this is LTE radio as opposed to new radio. What's the point of this? Why make things so complicated? Well, you can imagine some operator that has lots of connected things over LTE. Hundreds of thousands or millions of connected meters and sensors. And of course, this operator does not want to replace all these meters and sensors and things just because they are rolling out 5G. Because, I mean, replacing lots of things costs a lot of money. So having an NG node B means that the connected UEs will still use the LTE radio interface. But since we have the N2, N3 interfaces here, they can be connected using the 5G core network, provided, of course, that they support 5G NOS signaling, but that's a software update. Upgrading a device from LTE radio to new radio, that's different, more complicated update than just changing the NOS signaling protocol. So I'm sorry for all the acronyms here, and I realize that there's a risk of confusion here, like what's the difference between an ENG node B and an NG node B, but unfortunately this is the terminology used in the specification, so don't blame me for all the acronyms. All right, finally, I think, yeah, just like in 4G, it will be possible to use some non-3GPP access technology to, yeah, register in the 5G core and set up sessions. So this is a Wi-Fi access point, pretty much like this is a Wi-Fi access point. These are typically not owned by the telecom operator. I mean, these are the Wi-Fi access points that we have in our houses or apartments, that we have in cafes and the restaurants and hotels. So using untrusted non-3GPP access, because this is from the operator's point of view, it's an untrusted, uncontrolled Wi-Fi access point. It means that on the edge of the core network, the operator will put some type of border node, and in 5G this is called an non-3GPP interworking function. I will not talk very much about this in this course, or I will actually not talk about it at all, but of course the idea is very similar to what we are doing in 4G. If there's a nice Wi-Fi access network, and if the user equipment supports Wi-Fi, why not offload the operator's network and have traffic handled by somebody else's Wi-Fi network. So we can just make a little comment here. This is what they call non-3GPP access network. Typically, it will be Wi-Fi because there's Wi-Fi everywhere, more or less, and some fixed broadband connection, the regular internet connection, which we typically have from our houses. Wi-Fi plus fixed broad band like that. Great. That was the 5G system actually 5G system overview is the name of the whole course. This was the end of the first chapter, the 5G system overview. But actually the rest of the course, the rest of the week, we will talk about things in this picture. Next chapter will focus on the core network, these different network functions in the core network. What do they do? What happens when somebody registers? How do we set up this green line, the session? And of course, later we will talk about new radio. What is actually new about new radio? How is it different than old radio? And we will talk about the G-Node-Bs and the different protocols and interfaces here and towards the core network. We will try to figure out how we can create network slices. We will discuss edge computing. So pretty much the rest of the course will be about things I have at least mentioned in this first chapter. All right. When was the last break? A while ago. Let's do like this. Let's have a 10-minute break, and then we will go into the next chapter of the course.
Great, thank you.
Oh. All right, welcome back, and I will now move to the next chapter, picture. Which is about the core network. So the rest of today and starting tomorrow, we will talk about the core network. So the NG-RON is now just a little box here. And of course, we will open this box later on. But for now, NG-RON is just a little rectangle here. But as we know now, this is where we have G-node Bs. And this is also where we have the NG E-node Bs, the 4G base stations with N2 and N3 interfaces to the 5GCore, which we discussed just before the break. From the core network's perspective, NG-RON provides us with radio resources over the radio interface, and we have mainly two types of radio resources. We have radio resources which we use for different types of control plane signaling, and we have radio resources that we use for the data traffic. So we can just indicate that over the radio interface we have so-called signaling radio bearers. They are red because we use them for control plane signaling. SRB or SRBs. And then we have the green radio bearers, and they are called DRBs, as in data radio DRB. And in the end, SRBs and DRBs will be new radio waves on some nice frequency band. But once again, from the core network perspective, yeah, we have radio bearers. That's all the core network really needs to know. All right. Yeah, this part of the picture is often referred to as the service-based architecture, which is also the subtitle here. And a common way to draw the service-based architecture is to have, yeah, boxes, rectangles connected to a long kind of bus like this. What this means is that basically they can all talk to each other, of course, over IP. So physically this is not a data bus. Physically this is an IP network, but they can, in principle, all talk to each other, the boxes or the network functions inside this service-based architecture. And one reason why they can all talk to each other is that they speak the same protocol. Communication here between this box and that box, or that box and that box, all uses HTTP, Hypertext Transfer Protocol. So no more SS7 signaling, no more diameter, which was one of the big new things in 4G. This time the communication protocol here is HTTP. So let's take a look at the things. in the service-based architecture or on the service-based architecture. Or by the way, first of all, there are some references here. These are references to 3D people specifications. So a good starting point to read about the 5GCore is 23501. There are additional details in 23502 and 29500. And while we are here, we can also define the colors. So red will be our control plane color and green will be our user plane color. All right, let's start with UDM, Unified Data Management. And short explanation, this is the subscriber database in 5G. In 2G and 3G, there is the HLR. In 4G, we have the HSS. And in 5G, it's called the UDM. And I've indicated with some lines here, well, maybe you don't even have the papers, but still, this indicates where to write. So in the UDM, there is subscriber data. Identities for subscribers. We will talk more about this in a little while. Yeah, other profiles. Is this a high priority subscriber? Is this a low priority subscriber? Maybe, yeah, kind of the normal subscriber data. Fairly static. Subscriber data doesn't change until the subscription changes. But there is also some more short-lived or dynamic information stored in the UDM. And we usually call this UE context, like this. And we can describe this as information about a user equipment. Is the user equipment registered or not? Is there an ongoing session? That's not really part of the subscriber data. Whether you are registered or not, whether you have a session or not, this is more dynamic information. But also this type of information can be stored in the UDM. Great. So obviously, subscriber data is about, well, part of the subscriber is identities for the subscriber. And we can discuss this a little bit over here on this part of the paper. There will be 1, 2, 3, 4, 7 lines of text here. So I will start fairly up, high up here. UE identities. Great. The permanent identity of a 5G subscriber, the identity which defines the subscriber or the subscription is called subscriber permanent identity, or shorter, the SUPI. And it says in the 5G specifications that a subscriber permanent identity can have different formats. One of the formats is the good old IMSI identity, the IMSI number, which we have been using in 2G and 3G and 4G. But the SUPI is not necessarily in the format of an IMSI identity. It can also have some other format. Last time I checked in the specifications, there was no other format defined than the IMSI format. But maybe in a few years, the car industry or the refrigerator industry or the coffee machine industry will say, we have a better idea. We don't want to use IMSI identities. We would like to use some other format for our types of things. The device itself, the smartphone or the actual hardware, also has an identity, which is not really associated with the subscription because we can change devices. And in 5G, this is called a permanent equipment identity. Good name. Permanent equipment identity permanently identifies a device, the hardware. This can be an international mobile equipment identity, but it can also be some other type of identity. So this identifies the subscription, this identifies the device. If this is some type of phone or smartphone, which we want to be able to use for voice calls, it will need to have a phone number or at least some IMS identity, like what's it called, IMPE, IMS Public User Identity, well, something which is roughly a phone number. In 5G, this is called GPSI, generic public subscription identity or identifier. I can't remember which. So this is some type of external identity that somebody outside the 5G system can use to contact the user equipment. And I think the most obvious example is a phone number, but once again, if the user equipment is a coffee machine or a refrigerator, maybe a phone number is not the most obvious identity for the user equipment. So the 5G specifications allow for other types of generic public subscription identities. But It can be an MS-ISDN number. MS-ISDN number is what we normally call a phone number. There are temporary identities allocated. Obviously, we try to avoid to use the real subscriber permanent identity. Actually, we in fact we never use it over the radio interface. So, well, just like in 2G and 3G and 4G, the network will allocate various temporary identities when it communicates with the user equipment to, increase the level of security. So in 5G, we have something which is called the 5G globally unique temporary identity. So basically, when you register in an AMF, the AMF will send a response and say, okay, welcome to the network. From now on, you have 5G GUTI number such and such. And this is the identity that the network will use when it communicates with the user equipment. Similarly, in the radio network will use short radio identities when it assigns and reassigns radio resources. These are called radio network temporary identities. And there are a few different so-called radio network temporary identities. If you are radio guys or girls, you know about this. If you're not, maybe you don't need to know the details. And finally, if we do things over IP in the 5G network, which is of course very possible, the user equipment will need to have an IP address. And normally this will be a temporarily allocated IP address from the network. So maybe it sounds like a trivial thing to say, who is the user equipment? How is the user equipment identified? But in reality, it very much depends on how we look at it. From a subscription point of view, the SUPI. From an equipment point of view, it has a pay. From an external point of view, there is a generic public subscription identifier. There are temporary identifiers, and once again, in order to do things over IP, the user equipment will need to have an IP address. Great. We have some lines here in the picture. This line here represents the N1 interface. If you remember, the interface which allows the user equipment to exchange NOS signaling with the core network. So we can this is a logical interface. So physically, communication goes over the radio interface, and then the G node B, or possibly the NGE node B, will relay the messages to the AMF and also vice versa. But for NAS messages, non-access stratum type of signaling messages, the radio network is transparent. It will not do anything. It will just like relay NAS signaling between the user equipment and the AMF. So logically, we have this N1 interface, but in reality, things are sent over the radio interface, and then things are sent over the N2 interface. Great. So when a user equipment wants to register in the 5G network because it has been switched on, or because some application has started which requires it to be registered, it will register in the AMF, Access and Mobility Management Function. So we can, well, or I will use this space to write a few things about the AMF. And I will use black because it's just text. Registration. When 5G UEs are registered, they will be registered in an AMF somewhere. In the home network, if you're at home, in a visited network, if you are roaming, but you need to be registered somewhere in order to be kind of part of the system. Yeah, we can take a look at the registration procedure. I will show you PowerPoint. Yeah, you have some references here, and it says, yeah, a UE needs to register in the network in order to use services, in order to handle mobility, and in order to be reached. It makes sense. When you switch on your device, for instance, there will be an initial registration. When you move across some area border, there will be a mobility registration because you have moved. There will be periodic registrations when some timer times out. So there are a few different types of registrations. One scenario looks like this, initial registration. So a user equipment has been switched on somewhere. It has selected a PLMN, a network. It has selected an access network. So access network in this case will be NG-RAN. And yeah, it will send a registration request. It will go over the radio interface, obviously. And the radio access network will select a suitable AMF for the registration based on, yeah, some hopefully intelligent logic. We can come back to that later on. In the registration request, the user equipment will indicate, yeah, what type of registration is this? Is this initial registration, or is it a mobility registration, or is it a periodic registration? It will identify itself, and here it says Suki. This is short for subscriber concealed identity. This is an encrypted version of the SUPI identity. So, and obviously for security reasons, we don't like to send the real identity of the radio interface. So this is a new feature in 5G. Before sending the SUPI identity, it will be encrypted, and it's called a SUCI or SUCI identity. Or the user equipment can identify itself with a 5G global unique temporary identity if it already has one. It depends. UE capabilities. I am this type of user equipment. I can also do LTE or I can not do LTE. So UE capabilities basically describe what can the user equipment do, what can it not do. Requested NSSAI. To make a long story short, this has to do with network slicing, and I will come back to it later. But in short, the user equipment says, I would like to belong to, or I would like to register in such and such type of slice. Maybe an EMBB slice, maybe an URLC slice, maybe an MMTC slice, if you remember the slices from the PowerPoint presentation this morning. All right, AMF will select an authentication server function, AUSF, and this is of course in order to do authentication. The AMF does not do the authentication itself. Instead, in 5G, we have a special box or function which does authentication. That's more or less it. And involving the authentication server function and the big subscriber database, the UDM, some type of authentication procedure will be done. And we will not go into the details here. AMF will then contact the UDM and say, subscriber such and such is now registered, and I am the AMF which is responsible for this subscriber. So I am handling this subscriber from now on. This is of course something that the UDM is interested in knowing. PCF, do you remember the policy control function? So in this example, because this is of course just an example, the AMF will contact the policy control function and ask, is there some access and or mobility related policy I should be aware of? Maybe the user equipment is a fixed device, a camera or a sensor somewhere. It should not move at all. In fact, if it moves, something is wrong. So mobility policy could be, don't accept any mobility, or allow the user equipment to move inside cell X, Y, and Z, but not outside that area, because this user equipment should be inside a factory. It can move inside the factory, but it should not move outside the factory. If the UE sits inside a truck or some type of production equipment. And then in response to the registration request, there will be a registration accept. Welcome to the network. This is your 5G globally unique temporary identity. This is your registration area that you can register in, etc., etc. Information that the user equipment needs to know. And that's basically the end of the registration procedure. If you know the procedure for registration in 2G and 3G and 4G, you will probably see that, it's kind of similar. It's not exactly the same, of course, but it's on a more philosophical level. It's quite similar to previous generations. All right, so obviously registration is a responsibility of the AMF. Mobility management, knowing where, or at least roughly where, a user equipment is. And the AMF uses the concept of a registration area. A user equipment will be registered inside a certain registration area. And a registration area can be, for instance, one or a few tracking areas. So just like in 4G, we have, cells are grouped into so-called tracking areas. And the reason why they have invented the term registration area is, once again, if you come from non-3GPP access, if you are using the Wi-Fi access point in the gym, you don't really belong to a cell, but still you are registered. So that would be another type of registration area. A non-3GPP type of registration area. A third thing, AMF is also responsible for reachability management. I will spell it correctly. Reachability. Reachability, MGMNT. What is this about? Well, a user equipment like this, I suppose, needs to be reachable more or less all the time, because maybe somebody will call, or there will be an incoming SMS, or somebody will contact me using Skype or whatever. But other UEs like meters or sensors, alarms, the kind of more simple, if you like, IoT devices, maybe they don't need to be reachable, or at least not all the time. If this is, once again, a power meter, and what it will do is that on first day every month, it will report the previous month's water or power consumption. It can basically go to sleep for 1 month, wake up, send its report, and then go back to sleep mode again. It doesn't really consume any radio resources. The battery lifetime can be very long because it sleeps most of the time. It also means that it will normally not be reachable. It will be registered, but it's not reachable because it's sleeping. Or maybe it will wake up during 5 minutes every Sunday morning if somebody, well, if the power company or water company wants to send a software update. So reachability management is about knowing which UEs are listening, which UEs are listening to the paging channel. And if they're not listening, when is the next time water meter such and such can be reached? Some tasks of the AMF. There are others too. AUSF, authentication server function, does authentication of UEs, and also in the same procedure, some keys will be generated, some security related keys, and that's it. UE authentication and generation of keys. And yeah, to make a long story short, these keys are used to produce ciphering keys and integrity keys and other types of security related keys. I am looking at my paper. Yeah. Great. So now, after 3.5 hours almost, we have managed to register a user equipment in the 5G network. And I think before we finish for today, it would also be nice to set up a session. We have roughly half an hour to go. Let's do like this. Let's have a 5-minute break, just a kind of short leg stretcher, and then we will go on. And I promise we will not finish after 1 o'clock. So we have no more than roughly half an hour left of today. But at least I need a 5-minute break. So see you again in a couple of minutes. Jag tänkte att man köpa grejer, alltså det känns så extremt fånigt. Ni har liksom ingen möjlighet att skriva expenses som APIs betalar. Alltså vi skulle skriva en utläggsrapport i princip. Då. Gör så här då.
Men jag menar, det går ju, det är ju bara att beställa hit i princip.
Ja, jag tänkte så här, alltså det här känns ju bara som det känns som att någon chef har liksom bara inte...
Right. Det är nog mer bara så man vill se till så att det blir dels att det är rätt lampa inom en rimlig prisram och så att det inte blir en massa extra kringutrustning bara för att skruva upp den och såna här saker.
Hey, hello. You should turn off your microphone, otherwise we can hear what you are saying.
Jag vill skicka någonting till Linda, för hon vet ju inte. Jag vill skicka någonting till henne där det är lite oklart. Jag vill veta exakt vad kostnaden. Vad det är som behövs. Liksom. Och sen är det nog frågan, så några av de här lamporna är ju kanske man behöver ersätta.
We don't hear you at all.
Oh, somebody else muted me. We can do like this. Okay. Sign language. All right. Is it okay now? Okay. You should be able to hear me now. Is that okay? Fantastic. Yeah. All right. The things I was saying was that this user equipment is registered. It has been authenticated by the authentication server function. The relevant part of the subscription profile has been fetched down from the UDM. So AMF knows everything it needs to know about the subscriber. Maybe also the AMF has asked the policy control function for any mobility related policies. How much or little is this user equipment allowed to move? Is it a smartphone? It can move basically anywhere on this planet, or is this a camera or an alarm which should not move at all? Now it's time to set up a session. The user equipment wants to set up a data session to data network X, Y, or Z. Once again, this can and will very often be the public internet. It can also be IMS, or it can be some other type of data network. There's a traffic case which I will show you tomorrow, but to make it simple, the user equipment will send some type of session setup request. It will go by the AMF because as we have tried to show in the picture, the single point of contact in the core network for the user equipment and also for the radio access network is the access and mobility management function. In order to set up a session, the user equipment really wants to talk to the session management function, but it will have to go via the AMF. AMF is of course more or less transparent. It will receive a session establishment request. The AMF will say, this is not for me, so I will forward this to my colleague, the session management function. So session management function will do a couple of things. Session authorization. Sorry about the lousy spelling. Authorization. Is this user equipment authorized to set up a session to this data network? If I want to use my iPhone, next time maybe I will have a 5G iPhone, to get internet access, that sounds reasonable. If I want to use my iPhone to set up a session to the power company in Stockholm, to their billing server, that, well, it would be good, but I don't think that session would be authorized because there's no reason why I should be able to communicate with the power company's data network from my smartphone. In that case, I would just send that, no, I didn't use any electricity last month, or I used a tiny amount. So can the session be authorized? If it's an IP session, which sounds quite reasonable, then the user equipment will need to get an IP address. This is also responsibility of the session management function. So the session management function will have a pool of IP addresses, and it will pick one of the currently unused IP addresses, and it will allocate it to the user equipment. And then for the actual session, we will need to have at least one or maybe a few UPFs, user plane functions. And the way this picture is drawn, it sounds like, or it looks like a easy decision, because there's only one user plane function to choose between. But of course, in a real network, the session management function will have to make some choice. So for this particular session, which user plane function or which user plane functions does it make sense to use? So the third thing we can write here is that the session management function selects and also controls UPF, or possibly more than one user plane function. So there is an interface here which allows a session management function to contact, in this case, this user plane function and say, hello, I would like you to be part of this PDU session. And this is what I would like you to do. So the session management function will send down instructions to the user plane function. Do this and this. Forward packets normally, but if you find packets with this type of profile, block them or redirect them, or basically, yeah, session management function will send down instructions to the user plane function about how the user plane function should behave. We will come back to this. Over the radio interface, there will be data radio bearer or data radio bearers set up. That's the radio access network's responsibility to figure out what type of radio resources shall be used for this session. We'll come back to this later in this course. Between the radio access network and the UPF, in this case the only UPF, what we will do is that we will do a really old mobile telecom trick. We will build a GTPU tunnel between the base station and the user plane function. So this kind of grayish pipe here represents a GTPU tunnel, and I will use the green pen because now we are obviously in the user plane. And yeah, I said this is one of the oldest tricks in mobile telecom. GTP is for GPRS tunneling protocol. So this goes back to the previous millennium. GTPU was appeared first time in the GPRS specifications in 1996 or 1997, a long time ago. But the concept of using tunnels, and in this case GTPU tunnels, is very good and efficient, and I will explain why later. So we use it in 2G for data traffic, we use it in 3G, we use it in 4G, and we also use it in 5G. Maybe we will use it in 6G and 7G, I don't know. But at least in 5G, there's a GTPU tunnel for tunneling traffic between the radio network and the user plane function in the core network. And there is one such GTPU tunnel for each PDU session. So the tunnel is UE specific and the tunnel is session specific. We can write that as a little comment here. One per session or one per PDU session. Yeah, by the way, this is the N3 interface. If you remember from the previous chapter. So sometimes this is called an N3 tunnel, but technically speaking, it's a GTPU tunnel. Great. So what we see in the picture, starting here and ending here, or vice versa. This is a PDU session. That's the kind of data session or data connection between the user equipment and the data network. So I'm going to color it green. Like this. And this arrow here represents once again PDU session. That's the official 5G name. Once again, I think outside the telecom industry, people would just call it a data connection, or I have internet access, or it's a data session, a protocol data unit session between the user equipment and some data network. So PDU, protocol data unit, is short for, PDU is short for protocol data unit. So what is then a protocol data unit? Well, it's some type of packet, to put it in a simple way. It can be an IP packet. And in that case, it can be an IPv4 packet, or it can be an IPv6 packet. Yeah, maybe I should clarify. I will zoom out. So the purpose of everything is that a user equipment wants to exchange protocol data units with something or somebody out here in the data network. Those protocol data units will be sent on data radio bearers here. They will be sent inside GTPU tunnels here. But the PDU, the protocol data unit, that is really what the user equipment and some counterpart are exchanging. And of course, we know that we can do a lot of things over IP. We can do web browsing and email and stream things over IP, and we can do voice over IP, etc., etc., etc. But a protocol data unit can also be some other type of packet, although we may not usually call it a packet. Instead, we can call it a frame. So a protocol data unit can be an Ethernet frame. Normal, good, old-fashioned Ethernet frame. It's a packet, although we call it a frame for historical reasons. And of course, in the Ethernet frame, there's a header. We don't have IP addresses. Instead, we have MAC addresses, and then there's a payload. Or a protocol data unit can be something else. Neither an IP packet or an Ethernet frame. It can be some other type of packet. And this is in the specifications called unstructured. Sorry. Unstructured, which basically means some other type of packet. Oh, there's a typo here, but I will not bother to correct it. So this is, of course, to make 5G forward compatible, if there is such a word. Maybe in a few years, once again, the vehicle industry or the coffee machine industry or some other vertical will say that, no, we don't want to use IP. It's old-fashioned. It's a lot of overhead. We will not use Ethernet. We have our own protocol or our own protocol data units with some header format and some payload format, which is much more suitable for our type of vertical. And basically 5G allows some vertical to exchange any type of protocol data unit. Unstructured refers to that the 5G system really doesn't know how long is the header, what type of addresses do we have. In IP packets, there are IP addresses. In Ethernet frames, there are MAC addresses. In an unstructured packet, well, we don't know. The 5G system doesn't really know what the packet looks like. All right, so that's the session. And what the UPF will do is to forward protocol data units in this direction or in this direction, or maybe block PDUs, which we for some reason want to block. We can have blacklisted IP addresses, or we can have blacklisted applications. So the user plane function will, well, do some type of user plane handling or user plane traffic handling. UP as in user plane. Oh, sorry about the spelling. Traffic handling. And yeah, it can be forwarding, but it can also be blocking. It can be redirect. It can be take a copy of everything and send a copy to the lawful intercept department. So forwarding, blocking, etc. And it will also do QoS enforcement, QoS as in quality of service. The UPF will make sure that the maximum bit rate is not exceeded, and that if there is a shortage of resources, the sessions with higher priority shall be given higher priority, and maybe sessions with lower priority shall be downgraded or maybe even dropped altogether. So QoS enforcement like this. If there are several UPFs after each other, if there's one UPF here and then another UPF here, the interface between them is called the N9 interface. So I think what we try to show here is the N9 interface. Unfortunately, I don't have any space, or maybe I have. Well, so and so. In a roaming scenario, for instance, there will be one user plane function at least in the visitor network, and there will be one user plane function in the home network. In 4G, we talk about serving gateway and packet data network gateway, S gateway and P gateway. In 5G, we just talk about UPFs. We make no distinction between serving UPF and packet data network UPF. They're just called UPFs. All right, so now after almost 4 hours, we have managed to set up a session, which is good. Before we finish for today, yeah, there are some interfaces. So here we have N1, here we have N2, here we have N3. The interface between the session management function and the UPF is called N4, and I'll use black because it's both a control plane interface and a user plane interface. When the session management function gives instructions order to the user plane function, obviously that's red control plane signaling, but there will also be situations, or there can be situations, when we transfer green user plane data between the UPF and the SMF, and I will come back to this later on in the course. So that's why I'm using the black color. And then finally, the external interface on the kind of outside of the UPF. This is not called the N5 interface, which maybe would be the logical assumption. This is called the N6 interface because N5 is somewhere else. And yeah, if we compare this to 2G and 3G and 4G, it's called the GI interface in 2G and 3G. It's called the SGI interface in 4G. So N6 is the kind of same or similar interface. Great. So once again, we finally managed to set up a session and to connect the user equipment to the data network here. There are lots of boxes up here with cool acronyms, which we haven't talked about yet, but we will save that for tomorrow. It's almost 1 o'clock, so I think I have covered what I was planning to cover today, so I think this is a good time to stop for today and see you again tomorrow morning. I will start 9 o'clock sharp, so make sure you are logged on to the session. Great, thank you for today and see you again tomorrow morning.
you